Anytime you are going to have example where every single term in the equation is going to contain the logarithm, make sure that you are going to have coefficients next to the logarithms equal 1. I have coefficient 1, invisible 1, next to this logarithm, and I have 1 next to the logarithm on the right side of my equation. The middle logarithm has coefficient 3. So what I'm going to do, I'm going to use the property for the logarithm of power, and I'm going to move this coefficient to the exponent place. Logarithm x plus logarithm 2 to the third power is equal logarithm 2 over x. Let's take a look at the left side. At the left side we have the sum of two logarithms. These two logarithms have the same base. When they have the same base, I can use the property for the logarithm of the product. And the left side is going to look like this right now. I have logarithm of 2 to the third power times x is equal logarithm of 2 over x. When you have a situation that on the both sides you have log and log, you can drop these two logs and write your equation without the log. 2 to the third in this case is equal 8x equals 2 over x. Next we're supposed to use algebra to find value of x. In order to find value of x, I have to multiply both sides of the equation by x, because I want to eliminate the fraction first. So I'm going to multiply by x and multiply by x. X and x will cancel out, and I'm going to have 8x squared equals 2. In order to find value of x, I have to divide both sides equation by 8. 8 and 8 will cancel out, and I'm going to have x squared equals, I can reduce this fraction by 2. 2 divided by 2 is 1 over 4. So x squared is equal 1/4. If you want to find x, this is going to be equal plus minus square root of 1/4, which is equal plus minus 1/2. Let's check how it is going to work in our problem. If I'm going to consider x equals positive 1/2, if I'm going to apply positive value instead of this x into the first logarithm, my domain for this logarithm is going to be positive. So according to the definition, everything is okay. If I'm going to apply positive value to the denominator of this fraction, the domain of this logarithm is going to be positive. According to the definition, this is okay. But keep in mind, we have two answers. We have also negative 1/2. If you are going to apply negative value instead of this x, you are going to go against the definition, because x must be always be positive. I mean, the domain of the logarithm has to be positive. If you got negative, the answer is wrong. So the only correct answer for this problem is x equals 1/2.